Hello everybody, welcome back to my channel. Today we're going to be talking a little bit more in depth about JavaScript. Some things that you may be familiar with, you may not be. Things that may be happening behind the scenes that your linter is taking care of for you, or that you never really thought that deeply about. But I think it's going to make all of us much better developers, at least in the web sphere, if we understand what's happening underneath the hood. For those of you who don't know me, my name is Howie Reith. I'm a software developer. I'm all about trying to become the best developer I can be as quickly as I can be, and part of that means teaching what I know to other people. I feel like that's the best way to solidify the stuff in my own mind, and it benefits everybody. So let's talk about what we're going to talk about. We're going to be doing hoisting and scope in JavaScript, some specific concerns with that. We're going to talk about how variable references work and a little bit about how JavaScript deals with memory. We're going to talk about how JavaScript does classes and its prototypal inheritance. And finally, we're going to talk about how its fat arrow functions, or otherwise known as lambda functions, and some concerns regarding that and when to and not to use them. So starting with hoisting and scope. So here's a question for you. What is the most valuable feature contributed in ES6? Now obviously, this is a matter of opinion. I'm at the end of this, y'all may still disagree with me, but I'm pretty sure I know what it is, and let's talk about it. So in languages based on C syntax, which was originally BCPL syntax, we're using curly braces to define scope. And when we're talking about scope, we're talking about the context in which a variable is associated with a value. So if I define a variable inside of these curly braces, I can't access that variable outside of those curly braces. That variable is scoped to within those curly braces. So this is just some C code right here, and I am talking about specifically these curly braces right here. If I were to define any variables inside of this, or obviously this is int main, if I were to have stuff inside of main there, every single curly brace would be the definition of a scope, right? And this is a pattern we depend on for languages like Java, C#, Swift, Perl. There's a whole lot of languages that use this design. So let's consider a few situations in JavaScript. Let's look at var example1 equals banana. And this is just the Chrome console I have set up right here. Now if I were to type in example1, boom. This is a globally defined variable. I have access to it anywhere in the code, and so we are storing banana inside of example1. So now we have this function here, this example function, and we're going to bring that over into our console, and we have inside of it example2. Now if I were to try to access example2 outside of those curly braces, it says example2 is not defined, right? If I were inside of those curly braces, I could access it, but since I'm outside of it right now, I don't have access. So wonderful. Now we're going to do if true var example3 equals blueberry. So once again, I'm sure I will not have access. Oh, interesting. In this context, even though I'm not inside the curly braces, I have access to example3. Let's look at a few more examples. So last time it was an if statement. Does it work the same way with false? Do I have access to example4? I do not. So it looks like we never actually got into that if block, and so example4 was never defined for us. What about a for loop? If I have a for loop here, do I have access to... I do have access to example5. Oh man. Well, okay, so what's going on here? So JavaScript is designed for you to have access to variables no matter where you define them in your scope. So what it does is it takes your variables and it hoists the declaration of variables up to the top of the interpreted file. So even if you declare your variables at the bottom of your file, you will have access to them at the top. Now, to clarify this is declarations, not initializations. So for example, if I were to do this guy right here, what is that console log going to show? It's undefined. The reason it is undefined is because we are initializing example after we are attempting to console log it. Since example is undefined at this point, it is going to be undefined when it tries to console log it. But in this example, we are initializing example2, then we are console logging example2, and then we are declaring example2 to be something different. So what is that console log going to print out right here? It prints out Beverly Crusher. And the reason it prints out Beverly Crusher instead of Wesley Crusher is because once it has been defined, when it is actually interpreting the code, it hoists this declaration of example2 up to the top of the interpreted file. And then when it console logs it, it says, oh, okay, I see that at the top of this interpreted file, you set example2 equal to Beverly Crusher, so I'm going to console log Beverly Crusher. Okay, so behind the scenes, there's this hoisting behavior where you are moving declarations of variables and handling your variables in a different manner than you might suspect based on the order in which you have written your code. So that is relevant because it matters for how it is dealing with the curly braces. And what's happening is that these variables that are being defined inside of these curly braces, JavaScript is only respecting the curly braces that have to do with functions. If you declare or initialize a variable inside of curly braces, but it's for anything other than a function, or I suppose an object, then it is going to declare that variable. It's going to initialize that variable in the global scope, or to the highest point until it reaches the scope of a function, right? So it's going to go to the top of the function, or if you're already outside of a function, it's going to hoist it all the way up to the top of the global scope. It is not going to respect your curly braces. Okay, this is really, really bad. The fact that it does this hoisting behavior at all can cause a lot of problems, and the fact that it has this counterintuitive behavior where you think you have a scope, because every other language that you've worked in has this scope, but not JavaScript, that can lead to some very bad stuff. So, in particular, it causes unpredictable behavior in your code. So let's say we have the same variable used in different points in our code base. I mean, how many times have you written a for loop that's using I? How many times are you using the variable num? Or something along those lines, right? You can have many different situations when you have the same variable names used over and over again. Well, if these variable names are being hoisted up to global scope, and you're accessing them in global scope, then what's going to happen is you might get compilation errors as you have your variable declarations colliding with one another, or perhaps it goes through, and you wind up setting your variables to different things in different parts of your software, and the variable that you are expecting to have a particular value at a given point is going to have a different value from what you expect. And then your code's not going to behave the way you expect it to, and it's going to be very difficult to debug. This gets even worse if you start importing libraries into your code. What if your library is hoisting stuff up to the global scope and is using a variable name that's the same as you are using? The library could wind up bleeding into your code and breaking your code, or you could be breaking your library. It also makes your code a lot less readable. Let's say you know that this is happening, and so you're deliberately setting these variables to be in global scope. So you set it here, and then you access it in another part of your code, and another engineer is looking at this trying to figure it out. It's like, where the hell is this declared? What's going on here? I don't know what pattern is here. Why is this variable equal to 17? I don't see where it's declared as 17. So it's going to be that much more difficult to follow your code. One of the things that I hate most about this is the implications for testing. So every single time you need to do a unit test for one of these things, you need to bring in the entire global scope. Otherwise, your test is going to be like, oh, I'm expecting this thing to be defined, but it's not defined. What are you doing, programmer? Or your tests could wind up bleeding into one another. It can cause a lot of unexpected behaviors. So, and every time your functions are mutating a global variable, then that means that your function depends on global variables. And so it makes your code that much more difficult to make modular. Every single function that you have is going to be dependent on everything else. You can't have localized modules that you test and can move to use in different parts of your code. Everything is dependent on everything else, and it just becomes this big ball of yarn that becomes progressively more difficult to maintain. So it just gets really, really nasty. Let's look at one thing that makes this even worse. So far, we have not had example 6 inside of our console over here. And just to prove it to you, I'm going to refresh, so this is a totally new console. Example 6 equals orange. Now, I didn't use let, but look, the browser is okay with example 6 being in there. I didn't have to use var or anything to initialize it. So what JavaScript does for you as a favor is if you forget to say var, it's like, aw, I know what you meant. You meant to initialize this variable with this value. I'm just going to go ahead and hoist that up to the global scope for you. It'll be all good, right? So this was originally intended to make onboarding onto JavaScript easier. It was supposed to be friendly to new developers. But the ultimate consequence, in combination with the fact that everything's being hoisted up to global scope, is it's a bug factory. It's like, am I initializing this, or am I accessing something that I'm expecting to be there? I don't know. Neither does new developer who's coding along and trying to figure this stuff out. So, yeah, this is kind of terrifying when you're looking at it in context of like, how do I make sure that this code is readable and maintainable in the long term? So, let's look at our previous examples, but this time instead of using var, we're going to use let. Let and const were introduced in ES6. For a variety of reasons. They do more than just this, but one thing they do is they limit the scope of where they are active to within the curly braces as you would expect them to be. So we do let example 7 in an if statement, and if I do example 7, thankfully I do not have access to it outside of these curly braces. We can observe the exact same thing with example 8. Inside of the for loop. Since we're using let instead of var, it is not being hoisted up, it is sticking to inside of the context of these curly braces inside of our for loop. So, how do you deal with this? My suggestion for you is never use var. If you have access to ES6, always use let and const. It will save you so much trouble. In my opinion, this is the single biggest fix of ES6, the single best feature, because the lack of this was the single biggest flaw in JavaScript. So always use let and const. Now in the off chance, or in the unfortunate case that you do not have access to ES6 and you do not have access to let and const, you're probably going to need to change your coding patterns. Generally speaking, when we're doing clean code methodology, we want to be defining our variables at the location at which we're going to be using them. But since their declarations are going to be hoisted at the top of the file, in order to not obfuscate that reality, it may be in your best interest to declare all of your variables at the top of your file and then use them lower down in the bottom of your file. Just to make it clear, hey, programmer of the future, you need to know that all of these variables are up here and being declared, and I'm not going to surprise you with anything at the bottom of this file. So that's just a suggestion. There are plenty of alternate solutions to this, but by and large, if you can use let and const, do so. Do not use var. Alright, so moving on, let's talk about variable references. So consider we're dealing with the following challenge. Our application is suffering performance problems, and we want to perform a refactor. We know we have one particularly resource-intensive function, and it's called in various circumstances across our application. However, we do not know how many times this function is actually called in a typical user's behavior. So we'd like to track how many times this function is called, so that when we do our refactor and run our standard test suite, say a bunch of end-to-end tests, simulating user behavior, we know that we've reduced the number of times our app is using this function without reducing app functionality. Now, there are several ways that we could architect this in order to solve this problem. Honestly, what I'd probably wind up doing is I'd probably set a global variable that's going to track, you just increment it every single time this function is called, and you just increment it inside of that function. But let's say we can't do that, okay? For whatever reason, we are unwilling or unable to track it in a global variable, and we have, say we have a state management solution that we have, and we're just going to track it inside of that state management solution. And so what we need to do is we need to pass an argument into this function, and every single time the function runs, it is going to increment the value of this argument by 1. So here we go. We are going to define our counter right here. we're going to have our expensive function, and this expensive function is presumably doing many other things, but all we care about is the fact that it is incrementing this counter, and then we are going to call it 2 times. So, what will be the value of counter at the end of this code snippet? Alright, well, so we are going to call it, and I would expect counter is going to be equal to 0. Well, that's odd. I called that function 2 times, and it should have incremented it twice. Oh, maybe there's something going wrong with setting the default here, right? Maybe it's like doing some wonky, weird behavior where it's overriding it. Let's try it without that default value. It's still 0. Why is this function not incrementing my value even though I'm passing that in? Well, you know what, let's change things up a little bit. Instead of setting counter equal to 0, let's set counter equal to an object, and that object is going to have a count quality on it, a count property, and that count property is going to be set to 0 initially. And then instead of just doing a +1 to it, we're going to say, hey, object, take your count property and increment that by 1. So let's see how that goes. And now, if I were to do counter.count, hey, that's equal to 2. So something strange is going on here. Clearly, we are able to increment values, but when we passed in just a number, it wasn't working. We needed to pass in an object. What could be going wrong here? So let's talk a bit about memory allocation. So in most lower level languages, like C, for example, you need to define how you use memory. And this typically involves 3 steps. Memory allocation, when you define a variable and create a certain allocation of memory, a certain number of bytes and so on, that you are going to allocate to storing the information that you're storing at this point in memory. The actual use of that memory, when you modify your memory allocation to have the values that you want to have inside of it, and then the memory release. So this is, you have successfully run your function, you have done everything that you need to do with this memory, so you are going to clean up that memory, you're going to zero it out so that it is available for other functions in your software to use. Now JavaScript, for better or worse, takes care of this behind the scenes for us. We don't need to do any of this allocation. It has its own ways of doing allocation and cleaning it up for us and deciding when it is done. So the way JavaScript does this is it has 2 pools of memory. It has the stack and it has the memory heap. Now, they behave in different ways according to the data structure that they are named for. You can think of a stack as like a stack of plates. The first thing that you put in is going to be, the last thing that you put in is going to be the first thing out. And then a heap, which is also known as a priority queue, the highest priority things are going to be the first things out. At some point, I'm probably going to do a video series on data structures, but suffice to say, this is beyond the scope of this video. These are just different locations of memory that JavaScript is using, and for our purposes, that is essentially all you need to know. So the stack is reserved for static data. This is primitive data like numbers, strings, booleans, undefined, and null. And it also includes references. And what references are, is they are pointers to more complex data like objects and functions, non-primitives. And so the nice thing is that all of these static data types are of fixed size at compile time. So you can be extremely performant in the way that you're dealing with them. And thus, allocating memory in this way is known as static memory allocation. Now, the heap is responsible for dynamic data. This is your more complex stuff like objects and arrays and functions. So JavaScript does not allocate a fixed set of memory for this. Rather, it allocates memory to the heap as it is needed. And this process is called dynamic memory allocation. So as such, when you create a variable and store it in memory, like let counter equal 0, this counter variable is being stored in the stack with its value. And then when you create an object, like let counter equals count:0, like so, 2 things are actually happening here. One, you are allocating memory in the heap to store the actual data for the object, and 2, you are creating a pointer to that object in the heap memory inside of your stack. And that pointer is the reference. So that pointer is a fixed length, and so it is a static data type, but it is pointing to the more complex data in the memory heap. This, by the way, is why creating copies of objects is relatively awkward in JavaScript. So if you were to copy a variable, like we were to copy our counter object as second counter like this, when you do it this way, you are copying the reference. You are copying the pointer that you have in the stack that is pointing to the object in the memory heap. No new object is being saved in the heap memory. All you're doing is creating another pointer. And this is what it's called a shallow copy. So if you were to add another value to second counter, for example, second counter.fruit equals banana. If I were to then do counter.fruit, it would return to me banana because they are pointing to the exact same object in memory. The same object has been modified. It is only the pointers that are different. So if you wish to create a true copy, a deep copy, in which you create a brand new object in the heap memory, you need to actually do exactly that. And the simplest, there's many ways to do that in JavaScript, but the simplest way, the most common way, is probably to use object.assign, that method on the object prototype, and it would look something like this. So why didn't our expensive function counter work? Well, when you pass the variable into the function, JavaScript initializes that variable on the stack and sets it to what we passed in. So if we pass a primitive, it's setting that actual value on the stack. But if we pass in an object, it is setting a pointer that is pointing to an object in the heap memory. So, and then when the function completes, JavaScript's garbage collector comes by and says, oh, hey, we're all done with this memory allocation, I can clean it up. So those values that we set, that pointer equals pointer plus 1 that we did inside of the function, that goes away. That is popped off the stack because it's not necessary anymore. But when we modify the heap, the object that is being stored in the memory heap, that is going to persist. The pointer that was pointing to that object that was inside of the function, that is going to be garbage collected. But the object itself is going to stay. So when we create another pointer and look at that object, we'll once again be able to retrieve the modified data inside of that object. So that is the way memory is working. That is how references work. So when you are dealing with storing states, storing information in this way, be aware of which pool of memory in JavaScript you are using. Because if you think you're using one that you're not actually using, you could wind up losing data that you meant to keep, or keeping data that actually isn't that important to preserve. All right, so classes, prototypes, and ESX classes. So JavaScript is a functional, object-oriented language inspired by the practices of its peers. A lot of its syntax comes from Java, its function behavior is inspired by Scheme, its prototype inheritance comes from Self, its regular expressions are borrowed from Perl, and in ES6, async await was inspired by C#, and the spread operator was almost undoubtedly inspired by ML. In short, JavaScript is a mixture of many philosophies and values. Some of them are executed very well, and some of them not so much. And a lot of them are compromises. So let's talk about classes. In object-oriented languages like Java or C#, objects are based on classes, and a class you can think of as a blueprint from which objects are created. A class does not exist in memory. You can think of it as an execution script that's part of the language. You don't actually get consumption of memory until the class is instantiated as an instance of that class into an object. Now, when you have these objects, you can think of these classes also as contracts. Every single one of these objects you can count on having all of the qualities inherent to that class. So if this class has a property on it, you know that this object is going to have that property. If it has a method, that object will be able to have that method invoked from it. So let's have a look at some Java code. And just to be clear, this is Java. This is not JavaScript. Do not try to do this in JavaScript. So you see here, we're going to declare a class called cat. And this cat is going to have some properties and some methods on it. So notice when we're declaring these properties, we indicate whether it is public or private. Public means that anybody who accesses an object that is instantiated from this class is going to be able to access that property or that method. Int, in this case integer, is the type of the data type that this property is. So in this case, feet equals 4 because a cat has 4 feet. Ears equals 2, which is an integer, because the cat has 2 ears. All right? Our methods need to declare what type they are returning. In this case, the meow method doesn't actually return anything. So we're going to say that it returns void. All it's going to do is it's going to do Java's equivalent of a console.log, which is system out println meow. So notice that for these private methods right here, if I were to try to access this inside of a cat object, if I were to do, say, I'm going to instantiate cat here for Han, if I were to try to do han.per, I would not have access to this. However, inside of the object has access to all of its private methods. So what this is doing is this is doing information hiding. And what information hiding is it is a method of reducing the cognitive load that a developer needs to know in order to interact with an interface. We are designing a cat interface here. So the person who is accessing a cat and creating a cat should not need to know anything about per in order to get cat to behave the way you want cat to behave. When you are designing your objects, you're designing your interfaces, you should be designing them in such a way that you only need access to the public methods and the public attributes, and everything else should be hidden, encapsulated inside of the object in such a way that anyone who's working with it doesn't need to worry about it. This is a much bigger topic about what constitutes software simplicity and good software design, but that is the goal with object-oriented programming, is when you are designing your classes, you want to be designing them in such a way that the interface is all that the programmer needs to interact with in order to do the sorts of things that you expect this module to be doing. So let's have another look here at this code. So when you want to instantiate an object, you say what type it is. By the way, class and type very intermixed with one another. So this is a cat named Han, which is a new cat. Now I have Han, so I can do han.getPet. That's going to call getPet, which invokes the private method per, which is going to system out per. So let's see how that goes when we run it. And as you can see, it's system outed per. Now, another thing that you can do with classes is you can extend them. And what extends does is it says, okay, this class, I'm going to take everything that this class has, and I'm going to add some additional properties on it, and I'm going to call it a new class. So for example, if we have a Maine Coon cat, the Maine Coon extends cats, and Maine Coons are really big cats. So I am also going to take the public string size and set it equal to large for all objects that are Maine Coon cats. So when I instantiate Maine Coon in the form of Mr. Snugs, and I do mrsnugs.getPet, you will see, we can already see it here, getPet invoked per from its parent class, and when we system.out.printed mrsnugs.size, we could see that Mr. Snugs was indeed large. There is one more thing I will mention. You can have static methods on classes, which means that you can actually access those methods from the class. I could do capital cat dot and the static method's name, but the static methods are not actually stored as part of the class. The class is a reference to the static method. The static method is stored in its own little part of memory, and it's basically just a pointer that is being applied via the class. So that is just something I will mention if that was something that was confusing for you. but it is not particularly relevant. The main things that you need to understand here are in class-based systems, we have class inheritance when you extend things, we have private and public methods, and we have information hiding, the deliberate effort to keep some things private inside of the method, inside of the class, so that way you can't interfere with them, you can't mess with them. They are not meant to be interacted with when you access the interface, as opposed to public methods. And every single instantiation of a class must have all of the properties associated with that class, and if you want to change it, then you need to create a new class, usually extending it or creating something new altogether. So with classes out of the way, let's talk about prototypes. So if you can think of a class as a blueprint or a contract defining what an object contains, a prototype is, well, a prototype. It is the very first version of this object that you're going to be replicating over and over again. I sometimes like to use a biology example. Think of it like a bacterium. Bacterium contains all of the DNA that it needs for the bacterium to function. And when it goes through mitosis, when it splits and creates another bacterium from it, that bacterium is going to be an exact copy of the one that it just split from. So on it will be. Every single new bacterium that forms from those two is going to be a replication, and they're all going to have the same stuff. And over time, yeah, you can have mutations and so on, but for the sake of this discussion, let's think of it as like all of these new bacteria have everything that the original bacterium had. So the main difference between a prototype and a class is while a class is essentially an executable script within a language, a prototype is an actual object that is being copied over and over again. And thus it is often referred to as classless or instance-based programming. So just to reiterate some of the differences, there's no privacy in prototypes. Everything that is available on a prototype is publicly available on all objects that replicate from it. There are certain hacks you can do to try to get privacy in JavaScript, but we're not going over that right now. For our purposes, everything on a prototype is public. All objects, including initial prototypes, exist in memory, but an object using a method on its prototype will point to its prototype object to use that method rather than reinstantiating that method in memory a second time. So basically what it's going to do is, let's say I have an object. Let's say I have an array, right? Everything in JavaScript is an object, including arrays, and they all have prototypes on them. So an array has a .push object. So if I have an array that has, let's say, 1, 2, 3 on it, and I were to .push a 4 into this array, what JavaScript will do is it will look at my current array object and say, hey, array object, do you have a .push method on you? Oh, you do not? Okay. Well, then I am going to go to your prototype and say, hey, prototype for array, do you have a .push method on you? Oh, good, you do. Okay, I am going to run that method and do what that method says on this object. So thus, all of these methods, all of this stuff is stored only in a single place in memory. You're not replicating the same methods and properties over and over again in memory. You're basically like expanding the unique stuff into the new ones and only storing that in memory. So that is one of the advantages of prototypal inheritance, is that it can be efficient in that way. Now, typically, this is used in loosely typed languages because obviously if all of these prototypes can be modified and if all of these objects can have different stuff on them, however we see fit, it's going to be very difficult to enforce a strict type contract on all of these various classes that we're trying to do. Obviously, TypeScript is a thing, but we're talking about relatively vanilla JavaScript at the moment, maybe ES6 and so on, but that's all we're doing right now. We are not talking about it is loosely typed for our purposes. So let's do a similar object construction to what we just did with Java, but this time we're going to build it using JavaScript prototypes. So we have a cat, and a cat is going to have 4 feet, and it's going to have a purr function that is going to console.log purr out into the console. Now main coon is going to be a new object, and notice we haven't actually connected main coon to cat just yet. But if we were to do object.set prototype of main coon and cat, we have now applied the prototype of cat to main coon. And then if we were to do main coon.per, we would see that main coon now has access to everything that is on the cat prototype. Now this is a somewhat cart before the horse way to do this. Ordinarily what we're going to do is we are going to have a new variable that is going to be based on the prototype we want to do. In this case, we are treating the main coon object as our prototype, and we are using object.create, and Mr. Snugs is going to be a new main coon. If we take a look at Mr. Snugs.size, it's going to be large because that is on the prototype of the main coon cat. And if we were to do Mr. Snugs.per, then Mr. Snugs is going to purr because it looks in the main coon prototype, says, oh, I'm not here. So it goes all the way up to the cat prototype and says, oh, hey, I have a purr method. I'm going to run that. And Mr. Snugs purrs. So unlike with the bacterium example, when you update a prototype in JavaScript, it changes every object that inherits that prototype. So for example, if I were to modify the cat prototype right here, even though I have modified cat after I have created Mr. Snugs, if I then perform Mr. Snugs.sleep, Mr. Snugs does indeed console.log out the Z's. So Mr. Snugs, by virtue of the prototype having been updated, Mr. Snugs gains access to everything on that prototype. And again, that is because of the way prototypal inheritance works. We have updated the prototype that is being stored in the heap memory. And so when we are pointing to it via our other prototypes along the chain, when we access that method, it is now accessible to everybody who is pointing to that object. So it's important to know that this is prototypal inheritance, and everything in JavaScript is an object, and they all inherit from prototypes. So when you perform a .push on an array, you're using the .push method that is on the array prototype, which itself inherits from the object prototype. If I were to go in here, and I were to do array.prototype, you can see here a list of all of the methods and properties that are available to us on the array prototype, which are quite a few. So one cool thing about JavaScript is we can actually update the prototypes that are built into JavaScript. So, for example, JavaScript does not presently have a method on arrays that return the last item. So let's go ahead and fix that. I am going to create an array called myArray, and I am going to add a new method to the array prototype in JavaScript called last. And then, if I am going to call myArray.last, it is going to return to me the last item that is in the array. So this is now accessible for every single array that I ever write in my code from here on in, because the array prototype itself for my entire program has now been updated. So here's a challenge for you. In your Chrome console, or whatever you're working on, add a method to the prototype for string that will return the string with all white space from the end of the string removed. Call this method trim. Feel free to pause the video to do so. All right, we are back, and I am just going to give you my solution right here. So I'm going to do a little regular expression search right here, replace. And as you can see, banana split had a bunch of white space on the end. If I were to just do my string, you can see banana split still has it. But if I do my string.trim, then it returns a value without the white space at the end. So again, it's on the prototype, now available throughout our entire program. Use responsibly, but if used well, very, very powerful. So now let's talk about classes. So in ES6, a new class syntax was introduced that strongly resembles the syntax of class-based, object-oriented programming. While the syntax is similar, you need to understand that classes in JavaScript are not the same thing as classes built in strongly typed class-based languages. They are syntactical sugar built around prototypes. To illustrate this, let's take a look at how ES6 class syntax breaks down into earlier JavaScript versions. So here we've booted up es6console.com, and you can see here I have created a cat that has in the constructor function a parameter for favorite food, and it's going to set this.favoriteFood equal to favorite food. It also has a meow function that does a console.log of simply meow. We create a kitty, who is a new cat, and then we pass in Fancy Feast as its favorite food, and then we do kitty.meow. So how does this compile into ES5? So as you can see, it looks very, very different from what it is on the left. And let's actually take a closer look at this code in particular. So let's look at this create class function that showed up on the right side there. So this creates a function called define properties that accepts a target and the properties. And then for all of the properties, it is going to define a descriptor and then set descriptor.enumerable equals descriptor.enumerable, or false. It is going to set configurable for true if the value is in the descriptor, and then it's going to set writable equals to true. And then it is going to perform on the object prototype, and it is going to define the property of the target, which in this case is going to be the new cat object we are creating. It is going to pass in the descriptor.key, which is going to be the name of the property, and then the descriptor is going to be the value of the property. So essentially what it's doing is it is creating this new object called cat. And for every single property that we are using, that we are going to be defining on it, it is going through them and just tacking them on to this new object as prototype values. So just to slightly clarify exactly what's happening here, keep in mind when we are calling create class on cat, and we are passing in a key of meow and a value of function meow, console.log meow, that is exactly what is happening here, right? So cat is going to be the object on which we're applying things, and then key and value are this array of objects of props are going to be applied one by one with object.defineProperty onto cat. So if I were to take all of this code and bring it over to our console right here, and I were to do meowie equals new cat, and meowie likes tuna, meowie dot meow behaves exactly like we would expect. It behaves exactly like our ES6 class syntax, because this is exactly how it is compiling. So a few final thoughts on classes and prototypes. When you are creating classes in JavaScript or constructor functions in general, there is a convention that I think is a very good idea to follow, that they always start with a capital letter to differentiate them from other variables and functions. And the reason for this, to a large degree, this is going to be taken care of for you in ES6, because you will not be allowed to call a class creating function without the new operator. But there was a time when if you ever forgot to use the new operator on a constructor function, then what would happen is a lot of the variables that are being set inside of what you're intending to be your constructor function are actually going to wind up being set in the global scope, which can wreak havoc for all of the reasons that we've already gone over. So by convention, always name your constructor functions and your classes with a capital letter, so any other developer who's coming here knows, oh, this is a class, or oh, this is a constructor function. This always needs to be used with the new operator. If you are more familiar with class-based languages and you're learning about JavaScript anew, just be aware, like we said, these are prototypes, not classes. These are not enforced contracts. Just because you are using ES6 class syntax does not mean that this is going to behave like a class-based inheritance language. It is still a prototype. It still has all of the pros and cons of that architecture. There's no private variables. If you update one, you're going to update everything. You're not going to be prevented from updating anything. So be disciplined and make your choices deliberate as you are making them, and be careful that you understand all of the secondary consequences of the changes that you make to a prototype. That being said, it's a wonderful, wonderful thing. It's probably one of the best things about JavaScript, actually, is the way that it does prototypal inheritance. So make use of it. It's a potential alternative to closures as a way of making your application more modular and keeping track of state. So I'm a big fan of it. Just be aware of its pros and cons and its risks, and use it responsibly. All right, let's finish up our discussion on JavaScript for this video with fat arrow functions, or lambda functions. So there are several ways in JavaScript that we can declare functions. So first, and perhaps most simply, we have basic function declarations. So function, my function, with the curly braces, return 1 plus 1. So this is simply going to return 2. You are undoubtedly familiar with this if you have used JavaScript for more than 10 minutes. Next, we have a function expression. So in this case, instead of saying function my function, we are setting my function equal to a const, and we're saying, hey, you constant that I am just setting, you are equal to a function, and you are going to return 1 plus 1, right? More or less slightly different, ever so slightly different, but basically the same idea as what is happening with this right here. Next, we have the function constructor. So remember how everything in JavaScript is an object? Well, we can build a function object using the new syntax. So my function is a new capital F function, and this function, the contents of it is going to be return 1 plus 1. I do not recommend ever doing this, but it is a way that you can construct a function. And then lastly, well, there's many more, but the last one we're going to talk about is arrow functions, and these are sometimes referred to as lambdas because that's how this is referred to in other languages. But my function, so we do the parentheses right there in which we contain all of our parameters as usual, and then we have the fat arrow, which is an equal and then a right triangle, and then return 1 plus 1 blah, blah, blah. So this is essentially the same thing as the other ones. So there are a few more. There's generator functions and function shorthand, but we don't need to get into those. These ones are the most popular, especially this one, and this one. So what's the difference between these? We're going to focus on function declarations, which was the very first one, this guy right here, and arrow functions, this guy right here. So what's the difference between these, at least in terms of not just the syntax, but what really matters? Function declarations are statically scoped, while lambda functions are dynamically scoped. And what this means is that lambdas do not have their own execution context. Both this and their arguments are inherited from their parent functions. Now this can be a little bit difficult to understand, so let's illustrate it to make it a bit more clear. So I have an object here called functions. Functions, the object, has a description. Object with functions. Functions, the object, has two methods on it. It has create declared function, which is a function that is going to return a function. And this function that it returns is going to console.log this.description, and it's going to console.log any arguments that are passed in. Create arrow function is a function that returns a function. And the function that it returns is an arrow function. And that arrow function is going to console.log this.description and console.log arguments. Okay? A little bit confusing, but the difference is going to be clear in just a moment. Now I am going to declare a variable here called anonymous function. And I'm also going to declare a variable called arrow function. Now anonymous function is going to call functions.createDeclared function, and it is going to pass in as arguments banana and split. we're going to do the exact same thing with createArrow function. Now, when I call anonymous function, what are these console logs going to print out? Try and think about it for just a moment. Undefined, okay? It has no description and it has no arguments. Why? Because these arguments were passed into createDeclared function. They were not passed in to this function. Okay, does that make sense? And this description, this is scoped to this function right here. And the object that is this function does not have a property called a description. Therefore, this function has no arguments and no description. So when I tried to console.log them, they were both undefined. Now I am going to run arrow function. How is arrow function going to console.log this.description and this.arguments, knowing that I passed blueberry and pie into createArrow function? So here, arrow function description is object with functions, which is this description. It's the description of the encapsulating object functions. And the arguments that it receives are blueberry and pie, which are the arguments that were passed into the encapsulating function that was createArrow function. So this anonymous function, this arrow function right here, this guy starting at the parentheses, received the this and the arguments from the context that surrounded it. This is what is meant by static context versus dynamic context. The static context of the function declaration maintains this and the context of just the state within the function. But the fatArrow function inherits its state, inherits this, inherits its arguments from the context that surrounds it. Okay? I'm not sure I can make it more clear, so I'm going to move on, but that is definitely a confusing thing, so feel free to pause the video and experiment and mull that over for a few minutes, because it's going to be very important to understand the rest of this presentation. All right, moving on. One very popular use of arrow functions has been as a quick shorthand approach to binding a method to a class. So, we have a class that we have created called MathHelpers. And what we've done is we want to have on MathHelpers an add method. And an add is going to be a function that accepts two parameters, num1 and num2, and it's just going to add them together and return it. And by the way, with fatArrow syntax, if you have an inline just like this, you don't need to have a return statement. The lack of the curly braces around it implicitly says that you are going to return whatever this operation performs. We are also going to have a subtract method. And the subtract method, we are, instead of using the fatArrow syntax, we are going to use the traditional, at least in the context of a class, a traditional function method declaration. So it is a function, it is accepting num1 and num2, and it is going to return num1 minus num2. So const MathHelpers is going to be a new MathHelpers, and then we are going to call add inside of our code right here. Okay, so why is the fatArrow syntax a bit more popular? So let's say that we weren't just doing two parameters here. Let's say that we had values like first number is a property on MathHelpers, and second number is a property on MathHelpers. Maybe these are passed in the constructor or something like that. But add is actually going to be adding those two numbers together. So you need to do this dot num1 and this dot num2. In order for add to have access to this, ordinarily you would need to do something called a bind operation on add. That basically says, hey, add method, your context is going to be, your this is going to be inherited from the class that surrounds you. So then add is like, all right, I have access to the proper this now, I can now perform this dot blah, right? The nice thing about this fat arrow syntax is that it does that implicitly. It automatically inherits this from the context of the class that surrounds it. Thus, it's less code, it's simpler to look at, it makes it a lot more clear. Okay, this is the appeal of the fat arrow syntax. However, it has a lot of problems, and we're going to go over those right now. All right, so here I have taken our math helpers code and I have copied it over into this babel.js.io little console thing, and we are currently compiling it into ES 2017. So have a look at one thing in particular. So we have our subtract method right here, right? And when it transpiles over to ES 2017, it is essentially the same thing. It is a method on the class. But when we use the fat arrow function here for add, it does something different. It sticks it into the constructor, and then it performs define property on it in a similar way that we were talking about before, and it adds add to the prototype of the math helpers that we are doing. Now this may seem innocuous, but it is actually pretty significant and can cause a lot of problems. So the biggest issue with the fact that this compiles to this with the constructor function, as opposed to actually existing on the class, is that anything we make an arrow function will only be defined on the initialization of an instance of this class. It does not intrinsically exist on the prototype. So this means, for example, if we were to make another class that extended our math helpers class and tried to override our subtract method with a new one, our change would be overridden by the old version on the constructor every time we instantiated math helpers. So we have a new one that's on the prototype, but when we instantiate an object of math helpers, because it is in the constructor is going to run and override what we have on the prototype of our new extended class. Thus, it is always going to behave in the old fashion, and we're going to be confused as to why it is not doing it, because we look at all of our code, and our code seems to be exactly what we would expect it to be. It is an updated method on this class, and yet it is behaving in the old way. Why on earth is that happening? Very, very strange. Obviously, this is only going to happen if we make the extended item use function syntax while the original used fat arrow syntax, but that's not out of the question, and it will be a confusing behavior if we don't know about this. This also has some consequences for testing. In particular, if you mock subtract on your prototype in a test, it is then overridden by the constructor, and then you're sitting there like, why aren't my mocks manifesting in here? This is all very confusing. I don't understand, and you're going to need to spend many hours to find out why it is going wrong. It also introduces performance concerns. So since when you declare a method as a function and then you attach it to a prototype, this function only inhabits a single location in memory because it is on the prototype. Every time this function is called, it goes up along that prototype chain that we talked about, and it's called from that individual location. Since arrow functions are created every time we instantiate a class, each and every new instance of your object is going to create a new copy of that function in memory. So when you initialize many components, the consequences of this can be significant. So on the left side right here, this is operations per second with initialization. So the bottom is when we have nothing but function syntax. The top is when we have nothing but fat arrow syntax. And the middle is when we have function syntax that is binding using the bind language we will talk about very shortly. And then on the right side is operations per second when we are actually calling methods on our classes that we have instantiated. So as you can see, arrow functions are resoundingly less performant than simply using ordinary functions and binding them. So instead of using arrow syntax in classes, it is better for multiple reasons to bind the methods that need to have access to the context of this inside of those classes, and just use function syntax for the rest and don't bother binding them if they don't actually need access to this. So for example, the proper way to do this would be in class math helpers. Inside, let's say we're doing multiply and square, and thus square needs access to the multiply method, and thus it needs access to this. So multiply we do not actually need to bind, but square, what we're going to want to do is inside of the constructor, this.square equals this.square.bind this. That sets the context of this for our square method, and thus it is able to access this.multiply. And this avoids all of the hazards associated with making square a lambda function. So another place to avoid arrow functions is any situation in which you're using dynamic context. So some common examples of this: event handlers. Every time you use an event handler, say you're listening for a click or whatever, this by default is set to the event's current target attribute. If you use a lambda function when you are trying to deal with an event handler, this is not going to behave in the way that you expect it to, and it's probably not going to behave, it's not going to perform the task that you want it to. Very frequently when you're using jQuery, this is being set to the currently selected DOM element. If it is a lambda function, this is going to be something different. A lot of view functionalities, I've not personally used view in the past, but my understanding is that they typically dynamically set this to be relevant to the view components that you are currently working in. So if you are using a lambda function, this could wind up being set to something that you don't expect. Using arrow functions in these contexts is going to cause you a bit of woe, so it is better to just stick to normal function syntax. So where should you use arrow functions? Where will using arrow functions actually make your code better? Essentially, any time that you want to make use of that dynamic context, that it is appropriate, and especially in situations where the allocation of memory for this function is imminently going to be popped from the stack. So the most classic example is anytime you are iterating over a list using modern map or for each syntax, as opposed to, say, using a for loop with let I equal 0, blah, blah, blah. So if you're doing a map of a list of customers and you want to collect all of their IDs, you can map through them and use a fat arrow syntax in this context. That is an excellent and appropriate way to do it. In fact, I would say this is superior to using function syntax for the same thing. Likewise, if you are iterating through a list using for each, it could obviously make sense, or specifically in a situation that you need to have access to this, then you want to be using fat arrow syntax for that reason. So that way the this in this.customers is the same thing as the this that you're accessing in this.custnames.push. Also, anytime you're doing an asynchronous action, especially one that involves this, it very often makes sense to use a fat arrow, so that way your this remains consistent as you are performing the various operations that you need to do with it. There are some other ways. For example, if you are mapping values between objects and you need to be performing that update via a function, the execution of a function. For example, Vue makes use of this very often when it is mapping state. This is certainly an appropriate use for it as well. So by and large, what I would suggest is know that the lambda is an exceptional case, and you should be aware of the liabilities of using it. And if you are not aware of the liabilities of using it, or you don't have a specific reason, for example, a specific reason that you want to be binding the context of the lambda, you want to be absorbing the surrounding context as opposed to having the context bounds to within the function, make sure that you know what you're doing, okay? Make sure that you are using the lambda for a reason, not just because you heard it is the hip new modern way to be doing functions in JavaScript because it was introduced more recently than original function syntax, okay? You are using it because of its implications for scope and this and arguments passed in and so on. You're using it because of the way it is behaving in memory. you aren't using it because you are ignorant of how it is behaving in the memory. That is all I am suggesting here. So if you would like to know my citations for this, these are the 5 primary places I looked for this. I also got suggestions from my mentor, Dale Allishouse. You can see his blog at Hideous Humpback Freak. I will have it linked in the description. Thank you very much for watching. As always, if you have any questions, you can feel free to comment on this video. You can contact me at howard.reith@gmail.com. And I hope you found this video helpful and at least a little bit mind-blowing. I know when I was learning this stuff, a lot of this blew my mind, so perhaps you knew all of it, perhaps it was like, oh, my linter was taking care of this for me, but now I know why. So I hope this was insightful and provocative and helpful for you as a developer. Best of luck.